Okay, good afternoon, everyone. I am Afeen Kidwai, the editor-in-chief of solidwasteindia.com, India's only news and information website related to the solid waste. So now I would like to toss the session to Mark Döing. He's the manager of ecoprog. Ecoprog is a waste management consultancy based in Germany, and he will be moderating this session. Over to you, Mark.
Thank you very much, Afeen. Thank you very much. Yes, for me also a warm welcome, and thank you for showing up here, and thank all our speakers for finding the time and telling us something about their business. We have a very large amount of registrations received. Afeen, first of all, congratulations towards this, and thank you for organizing this event. I hope everything will go right. I think we did not prepare in the first way for such a large number of participants, but we hope that this will work out. Yes, we wanted to do a webinar and a number of webinars here for Solid Waste India. And as a first topic, we have chosen the RDF market, which is one of the most interesting market because as it is one of the market where waste really has a value. And this has led to a certain market activities. And of course, within such a small webinar like today, we cannot go to every detail. We have just a limited time. So there might be some question left, even for the large number of participants. We cannot answer all questions, but we probably will find time to do further webinars on the RDF market. For today, we are really happy and we are really proud to have 3 speakers for this topic, and I think it could not have been better than that. We have one of the largest RDF user in India. We have one of the largest producers of RDF in India, and we have one of the largest supplier of machinery for RDF production in the world. So I think, yeah, we have a pretty good lineup here, and thanks for being here to the speakers. I want to say we start in a different order than it has been written down on our website. So we start with Mr. Pahuja, telling us something about the use of RDF in the cement industry. Then Mr. Mallick will tell us something about the production of RDF, and Mr. Maistry will tell us something about the machinery to produce RDF. So we start with Mr. Pahuja. He's the Chief Sustainability Officer of Dalmia Cement, one of the largest cement companies in India, with 13 locations in 9 states, which in Germany would mean you would operate 1/3 of all cement plants in Germany. So it's pretty large. Mr. Pahuja has led the National Council for Cement and Building Materials as a Director General. He is the co-inventor of 16 patents related to the cement and building materials. He's associated with the cement sector for 42 years, so he's pretty experienced in this sector, and has recently been honored with the Asia Sustainability Executive of the Year in 2020. Mr. Pahuja, it's your turn. Thank you very much for being here today.
Thank you, Mark, for a very nice introduction. And at the outset, I would like to thank the Solid Waste India for having invited me to share our views on the alternative use perspective for the Indian cement industry, and also with a more focus on use of municipal solid waste and RDF for the Indian cement sector, and how are the potentials and prospects for this RDF for Indian cement industry. Can we go to the next slide, Afrin? India has been the most proactive on matters of related to resource efficiency, particularly material resource efficiency. with regard to utilization of alternative raw materials, where today it is using nearly 80 to 90 million tons of alternate raw materials, mainly as supplementary cementitious materials in the form of fly ash and slag. And also is one of the most energy efficient industry in the world as per the CSI ranking. And environmentally also it is very conscious. But in the field of alternate fuels, the cement industry has been a bit late starter. I would call it has been more because of the policy initiatives not very favorable for the alternative fuel scenario in the Indian cement sector, which now has become better, and gradually Indian cement industry has started focusing on alternative fuel utilization also, particularly in the last 5-6 years. Now, co-processing, as we know, for cement sector is a very important waste hierarchy. After reduce and reuse, the co-processing comes in the hierarchy, which is again considered as a recovery option. And all other options like incineration, landfilling, and uncontrolled burning are considered as disposal options. So it's a very important recovery option, creating a win-win situation, both for the polluter as well as for the cement sector. Next one, please. Can I have the next slide, Afrin? Now, why is cement sector for co-processing of the alternative fuels, which are particularly municipal and industrial waste? The main reasons are that the cement sector, having a temperature of around 1500 degrees Celsius inside the rotary kiln, provides a very high temperature and a very long residence time, and a very alkaline and oxidizing atmosphere, which results in destruction and removal efficiency of 99% or 99.9% of all the toxic elements. And the ashes also, which are created during the combustion, are also fully absorbed in the clinker structure. So there are no wastes as such. And clinker is also getting fully all the ashes, which also increases the utilization of the ashes. And as a result of which the complete scrubbing of exhaust gases also takes place. Next slide, please. Now, this utilization of alternate fuels in the cement sector started mainly in early 90s, and with only 2% of the alternate fuel thermal substitution in 1990 in the entire European Union. Today it has moved to around 48% in 2018, and currently it is again around close to 50-52% thermal substitution rate by the European Union. As against this, the Indian cement sector today is only at 4%. Well, there are reasons, as I mentioned earlier, that there have been not very favorable policy drives, but in the last few years, it has started picking up. Can we go to the next slide, please? As we see here, for different countries, for example, in Germany, the thermal substitution rate is around 65%. And Germany utilizes nearly 3 million tons of alternate fuels. Whereas in India, for a production capacity which is almost 10 times that of Germany, Germany has a production capacity of 34 million tons, India 334 million tons production. It stands only at 4% thermal substitution rate. But as we see, nearly 1.6 million tons of alternate fuels is utilized. So in terms of quantity is fairly significant, not that bad scenario, but in terms of percentage, because of the high capacity of the Indian cement sector, the percentages are low at 4%, and it desires a lot to be done in the field of alternate fuel utilization enhancement. Next slide, please. Now, the main fuels of the Indian cement industry has been coal and petcoke. And while the alternate fuel utilization started in a small way in the beginning of century, around 2001 to 2005, in a small way, it has remained up to 1% till around 4-5 years ago. And very recently, in last 5-6 years, it has picked up. And today, the thermal substitution rate has improved to nearly 4%. And various types of hazardous as well as non-hazardous alternate fuels, RDF, and plastic waste, etc., are being used by the Indian cement sector now. Now, in terms of thermal substitution rate, I would like to mention that though 4% seems very low, but the 4% thermal substitution in India is, in terms of quantity, it is equivalent to 100% thermal substitution rate of Australia. So that way, in terms of quantities, it's a very significant quantity, around 1.6 million tons of alternate fuels being used by the sector. Next slide, please. Now, coming to municipal solid waste, which is the topic of the day, or RDF. In India, the municipal solid waste generation is very high, which stands at nearly 65 million tons in 2018, and it is increasing at the rate of around 5 million tons, 5% annually. So that means today it should be around 75 to 80 million tons of MSW generated every year. And it is slated to increase to around 165 million tons by 2031. So the quantities are enormous. So as a result of which the potential is also enormous. But the main factor here is that only nearly 20% of the MSW is comprising of the combustible part, and the rest 80% is generally ashes and non-residual parts. Next slide, please. Now, when we talk of potential of alternate fuels in India, out of this RDF, nearly 9.46 million tons of out of this MSW, 9.46 RDF can be made available currently as per 2018 data, and nearly 4.5 million tons can become available to the cement sector. Apart from that, there is surplus biomass availability in huge quantities of around 145 million tons per annum, which is largely being either used by the renewable power sector or being disposed of at the site itself. Again, hazardous waste, close to 7.11 million tons of quantity is available, out of which nearly 0.71 million tons is only available to the cement sector for co-processing. And used tires, nearly 1.2 million tons is the availability. So total, we can say nearly 20 million tons is the likely availability of various alternate fuels in India. And we are using currently only 1.6 million tons. Next slide, please. Now, when we talk of RDF conversion derived from MSW, Indian MSW is not very good in quality because of the, as compared to European MSW, because of the difference in living standards of Indian population compared to Europe. So as a result of which the MSW has a calorific value of 1500 kilocalorie per kg or lower, which after treatment can be converted to around 3000 to 3500 kilocalories per kg in the RDF. Similarly, the moisture content is also very high. There are lots of food waste in the Indian MSW, because of which the biodegradables and food products are also very high, and moisture content is also very high. And in terms of utilization, if the cement industry is able to create a thermal substitution rate of nearly 20%, it can result in utilization of about 9.5 million tons of MSW by the cement sector alone. Next one, please. So the desirable characteristics of RDF from the point of view of proper utilization by the cement industry is that calorific value should be more than 3000 kilocalories per kg. Size should be preferably less than 50 millimeter for firing into the kiln. And if we have to use enhanced quantities, and if we have to fire inside the rotary kiln main burner, then it should be less than 20 millimeter. The ash content should preferably be lower than 15%. Moisture content again lower than 20%. Chlorine less than 1%, and sulfur also less than 1.5%. These are the desirable properties. But what we get is not exactly this. We get much poorer quality of RDF despite getting it pre-processed. So I'll share with you the actual values also in a few later slides. Next slide, please. Now these alternate fuels can be fired at various locations in the rotary kilns. The coarse fuels having 3D dimension of less than 50 millimeter can be fired in the calciner. And finer solid fuels can be fired inside the rotary kiln where the 3D dimension will be less than 5 millimeter and 2D dimension can be less than 30 millimeter. So fine fuels like rice husk, sawdust, or finely shredded or finely crushed RDF, etc., can be fired inside the rotary kiln main burner, while the coarse tire chips or shredded plastics or coarse RDF around 50 millimeter size can be fed into the main calciner of the rotary kiln process. And tires can be fired at the shredded tires can be fired at the calciner, and the lump whole solid full tires can be fired at the kiln inlet also. So this practice is generally not prevalent in India of firing of the whole tires in the kiln inlet. Generally, the firing is mostly being done at the calciner inlet by most plants. In very limited cases, the alternate fuel firing is being done at the main rotary kiln burner because the quantities handled are very small, and the first priority is to put all the alternative fuels in the calciner itself, which is more easy to handle. Next slide, please. While people feel that RDF, because it is having a calorific value, it is a direct coal replacement, it is actually not true. There are a lot of challenges when we try to use alternate fuels in the rotary kiln main burner as well as in the calciner. There are lots of process problems like ring formation, leading to kiln shell corrosion, unstable coating, increased circulation of various volatile elements and chlorides, dropping of unburnt fuels in the kiln leading to the process problems, lower refractory lifetime, etc. And also increase in the fuel consumption of the heat consumption of the rotary kilns. Next slide, please. And similarly, in the preheater and calciner, the problems of incomplete combustion, deterioration of the heat exchange because of the high amount of moisture also, and increased amount of waste gases or combustion products of combustion, increase in the dust cycles, post combustion taking place beyond the calciner because of the improper burning characteristics of the alternate fuels, and unburnt carbon falling into the kiln as a hot meal. So these are the problems which are faced, because of which it creates a challenge for increasing the utilization, and the system design has to be proper for tackling all these problems. While there are solutions for these, but still at the same time it results in additional equipment facilities to be installed at the plants, and a slight increase in heat consumption and slight reduction in the production of the kiln because of increased utilization of these alternate fuels. Next slide, please. Now I'll discuss about Dalmia Cement, how we are handling the alternate fuels at Dalmia Cements. We are advancing towards carbon negative 2040 goal. And so far in the year 2021, we have used 0.22 million tons of hazardous as well as non-hazardous waste as alternate fuels. And major contributions of this are coming from RDF, nearly 70,000 tons in 1 year, and plastics of around 50,000 tons have been used last year. As against the industry average of 4% thermal substitution rate, Dalmia Cement has used nearly 8.2% thermal substitution rate in the last year, and this year we are close to 9% above in terms of thermal substitution rate. Next one, please. Now the thermal substitution rate achieved for the year 2021, as I mentioned, was around 8.2%. And for some of the kilns, it has been as high as 18.5% and 16.8%, where we have got state-of-the-art facilities available, and where RDF is available in substantial quantities, the plants which are located near to the big cities. And in other locations, the quantities are low, in the range of 4 to 6% or 4 to 10%. In terms of types of alternative fuels, the major quantity is RDF, which is around 51% of the total alternate fuels used. And next is 27.7% of the plastic waste. And other wastes include various types of liquids, hazardous solids, non-hazardous solids, biomass, FMCG waste, etc., and also carbon black. Next slide, please. We have got state-of-the-art facilities installed at our plants for feeding of the RDF, and which have state-of-the-art imported shredders for reducing the size, proper screens for reducing the ash content, and also proper storage and feeding arrangements, and for proper feeding, as well as for minimizing the inconsistency in feeding, for proper control of the weight quantities of the alternative fuels. Next slide, please. Now, from current level of 9%, presently we have a target of going to thermal substitution rate of around 35% by the end of 22, for which we are taking a number of actions, which include installation of additional shredders and additional feeding equipment. We are upgrading our preheater fans for handling enhanced quantities of waste gases from the combustion of alternate fuels. We are carrying out calciner modifications for increasing the retention time of the alternate fuels. We are also in the process of installation of chlorine bypass systems for enhancing the alternate fuels in our kiln systems. And the group target is for 35% by March 2022. And beyond that, we have taken a target of becoming carbon neutral by 2040, for which we have a target of switching over to 100% fossil fuel substitution, that means 100% coal and petcoke replacement by 2035, for which it will be a combination of various types of alternate fuels, particularly RDF, and also a large proportion of biomass, which will be specifically sustainably harvested bamboo, for which we are going to have captive model of agroforestry for bamboo generation and bamboo plantation.
Mr. Pahuja, may I kindly remind you to come to an end? Your time.
Sure. Next slide, please. So, as I mentioned, that qualities of the RDF is not as per our desire. We require less than 20% moisture, whereas what we get is around 25 to 35% moisture. Similarly, ash is also we require less than 15%, whereas what we get is nearly 25 to 30%. So all these are creating process problems, as a result of which it's a challenge in increasing the quantities of RDF in our kilns. Next slide, please. Can we go to the next one? Yeah. So while we, depending on the availability of alternate fuels, we can fairly conclude that we can very safely go to a alternate fuel thermal substitution rate beyond 25% in next few years, but for which a regulatory push is required from waste generators as well as from government, which requires a balanced approach for market instruments as well as enforcement for policies for polluter to pay principle, and avoiding landfilling, so that majority of the alternate fuels can be actually co-processed and not actually dumped in the sites. So that with this, we feel that there is a big potential for enhancing the utilization of alternate fuels in the Indian cement industry. Next one, please. So with this, I would like to thank you for your patient hearing, and any questions, I'll be very happy to answer. Thank you.
Thank you, Mr. Pahuja, for this really, really interesting presentation. Before I start the question session, one remark to the other speakers. I think you can switch off your screen or your camera if you want to when you're not speaking, so you have a little bit more privacy. Mr. Pahuja, one question regards the costs of RDF. What are the costs or the gate fees of RDF in general in India, and are there different costs for different types or classes of RDF?
No, MOA has created 3 classes of RDF, but at present what the industry is getting only 1 class, as you mentioned, because there are not a large number of pre-processing facilities created. And again, gate fee also, most of the plants are getting at virtually either 0 or they have to bear the transportation cost. So at the moment, the principle of gate fee has not picked up. So that's why I mentioned that there is a need of a polluter to pay principle, so that if the gate fees are there, the industries will be able to create more or better pre-processing facilities for improving the quality of RDF, through which they can further increase the utilization of RDF for increasing the thermal substitution rates.
Can you give for a really complete ready-made RDF an overall price level in regard to rupees?
So in fact, in price levels, as you mentioned, that these are not, there is no organized price level. Individual plants are able to negotiate, and most plants are trying to negotiate that they should get it free of the cost at their gate, which in most cases is not becoming possible. So some of the plants are actually forced to bear the cost of transportation.
All right.
But luckily, there are certain small players who have started making payments also, which is around 50%, 50 to 70% of the cost of the pet coke. But the qualities of those types of RDF is very high, which is more than 4,500 kilocalorie per kg. But the quantities are very, very limited.
Yes, I understand. The quantities of that are difficult to get in Germany as well. Another question regards the pre-processing. You mentioned already that it's pre-processed, of course, it has to be. Is Dalmia also doing some form of pre-processing at the locations of their cement plants, or do they completely depend on other pre-processors who deliver it to your company?
Well, at the moment, we are taking only RDF, which is pre-processed, and we also are going to have some screens, but at the moment, we are not carrying out any pre-processing, except shredding. And shredding mainly to reduce the size, and screening to slightly reduce the ash content. But the main pre-processing plant, which requires proper dryers and separation of certain biodegradable waste, that is not available here. We do not have that kind of facility, because economics are not working in favor of that type of pre-processing. As I mentioned, that because the polluter to pay principle is not there.
Okay, thank you, Bharat. Probably one last question. You mentioned that you already, for instance, received biomass, and we also have a trend in India towards new waste to energy facilities. How is the competitive situation between the cement industry on the one hand side and biomass and waste to energy facilities who combust it as well on the other hand side?
Yeah, biomass is not priced very attractively. So generally the biomass supplier, they try to compare the cost of biomass with the cost of coal, and only advantage is that we get carbon footprint advantage, reduction in carbon footprint. So beyond that, once the carbon market is actually happening in the country, then biomass is likely to become very attractive. But at the moment, biomass is not very attractive from the point of view of pricing. Only the agriculture residues which are locally available, these are being made available. But the sustainably grown and harvested biomass will perhaps only become attractive when the carbon market happens or it takes place. so that we get added advantage of the reduced carbon footprint also because of use of biomass. So once that happens, then our plans are that we will go in for planned sustainable agro farming through cooperative farmer process, wherein we will be able to cultivate substantial quantities of biomass, particularly bamboo, which is a very fast going species. It is a local species which is having very high caloric value, close to around 4,000 kilocalorie per kg plus. And ash content is also very less. It has got low chlorides and low ash.
Okay. Thank you very much. We have some other questions. I have to apologize to the people here in the meeting, of course, with the participants, which are currently 140, if I understand it right. We cannot raise all questions, and some questions, such as the environmental impact of gasification, of course, would require, I don't know, a certain number of webinars, so they are difficult to answer. I hope to catch some of the questions for the final discussions at the end, if they fit into that, and kindly ask for your understanding that yeah, we cannot regard every question, because due to our time plan, we already have to come to our next speaker, to Mr. Mallick from Ramky Environment, or Ramky Enviro Engineers. I'm sorry for this. Ramky Environment is one of the leading waste management companies in India. I saw on your website, Mr. Mallick, you handle approximately 6 million tons per annum of MSW in 21 cities, and that is only the municipal waste and not the commercial waste. You oversee, personally oversee Ramky Enviro operations globally, and that of course makes you an expert in waste management in India. And you're also one of the advisors of the government of India. And you will tell us a little bit about the production of RDF. We just heard that probably there is not enough production or pre-sorting facilities for the production of RDF. So, Mr. Mallick, thank you very much for being here today, and we're looking excited to your presentation. Thank you.
Thank you so much, Mark, and thank you so much, Afreen, for organizing this this fantastic forum. It's really a great gathering and a very distinguished panel that I have the privilege to be a part of. Also, thank you to my previous speaker, Mr. Pahuja. I think he's made my job much easier because a lot of what I would have spoken about has already been appropriately and adequately covered. So I will quickly run through a few slides. These are obviously being developed from the context of a waste manager. And that's the journey that Ramky Enviro is in right now. It's from waste management to resource management, and one of the most significant levers in that journey is that of RDF, and so this is the waste management perspective or angle that I'll try to present. Also, to Mark's comment about me being an expert, actually, I think the only expertise that I've had is to lose a lot of money in the waste management space in the last 25 years and make a lot of mistakes as well. If that makes me an expert, so be it. But I'm happy to share some thoughts with you. The organization that I represent and I look after is called Ramky Enviro. It's one of the largest waste management companies in Asia. And it's actually up to about 7 million tons of waste handling annually. And these are now happening from about 80 odd facilities. The 65 number is old. And we're really proud to be part of an organization that now has 20,000 associates globally. And these are across many geographies. Our focus is emerging economies, the regions that need us the most. So obviously India, that's really where we started. But in Southeast Asia, we have a significant presence in Singapore with 2,500 people, a significant presence in many countries in Middle East where we manage different types of wastes. And we have recently established facilities in Africa as well as North America. So this is what our global footprint looks like. This is what we are within India. And within India, it's as Mark mentioned, about 6 million tons of municipal waste, about 1 million tons of industrial waste, about 60,000 tons of biomedical waste. We currently operate about 44 megawatts of waste energy plants, which we have developed. In addition to that, another 100 megawatts under development. This is very, very particular and pertinent to this discussion as well, and I'll come to that in a few minutes. But I wanted everyone to just look at a very quick look at this map. There are very few parts of the country where we are not, and increasingly, whether it is Northeast or Jammu and Kashmir, both are places where we have made an entry now. We have a facility under construction in Jammu and Kashmir. We have a facility under construction and actually 2 facilities under construction in Northeast. So those geographies that we were not covered whilst this map was made a few months ago are now covered. But that brings us to why all of us have come here today, which is to talk about the potential for RDF for municipal solid waste. Now, you heard all of these numbers. So let me just present the same numbers in a slightly different context. And the context is that irrespective of whether we are at 70 or 75 or 80 million tons today, everyone agrees that by 2030, in a few years from now, our urban municipal waste generation, this is not the total municipal waste, this is the urban municipal waste generation, will be 165 million tons per annum. It really dwarfs the 6-7 million tons that we currently manage. This is the scale of the challenge. Yeah, I would say this is also the scale of the opportunity. This represents about 41 million tons of carbon emissions equivalent per annum in 2030. So it's not just an issue of solid waste, it's also the resultant carbon footprint associated with this solid waste. Today, only about a fourth, 1 in 4 tons that is generated is being processed and treated. And that's also a reality. Again, sort of highlights the scale of the problem or maybe the opportunity, if one chooses to look at it this way. And if you were to landfill all of this, one would need a minimum of 66,000 hectares of land. And this is land that, that nobody wants, because I'm not so sure whether you would like, if I was to come to next to your house or your town or your village and say, I want to set up a solid waste management processing facility right next to your house or your town or your village. We as waste managers know this problem as NIMBY, not in my backyard. We all want waste managed, but not in my backyard. Where is this 66,000 hectares of land going to come from? In this country, where practically anywhere you go, there are people. Now, this is one set of facts. I think the previous speaker also highlighted. Let's talk about another set of facts. This is the changing composition of municipal solid waste in India. I've tried to use government data as much as possible in this presentation. This is Planning Commission data from a few years ago, which talks about between 1996 and 2001, which is not exactly a very, very long time frame, what exactly changed by way of composition. And you will notice that there has been a significant reduction in inert percentage over this time, and a significant corresponding increase in composition of paper, plastics, and some of the other recyclables, which is very, very interesting. This tells you that as an economy or a society evolves, matures, as income levels go up, consumption increases, the footprint of that increased consumption can be seen in the waste itself, not just in quantity terms, but also in composition terms. So it's not just the 5% growth rate that municipal solid waste has year over year. It is the combustible fraction or the energy containing fraction of waste that going up year over year, that is equally important for the discussion that we are having. So I actually tried to do this little table for you, which is this uses 2012 data, where the last time CPCB confirmed MSW generation in the country as 62 million tons, and the anticipated 140 odd million tons in 2025. That's the rough number that we are at right now. What does it mean from an RDF potential standpoint only from MSW? Pahuja Saab touched upon many other forms of alternate fuel. I'm only talking about municipal solid waste. And through a number of assumed factors, which is assuming a collection efficiency of 80%, which is correct, more or less where we are today. Collection, not processing. Collection efficiency of 80%. We will collect 112 million tons per annum of this 140 million tons that we generate. Processing or treatment efficiency, which is only 25% right now. I'm assuming this is going to grow substantially. We are actually seeing a lot of growth in the processing space in the next few years. I'm assuming that at 75% treatment efficiency, we will have 84 million tons of waste treated every year, which will, through a series of processing steps, represent about 13.5 million tons of RDF only from MSW. That has a very significant energy potential, etc. Not going too much into that, but I wanted to also present another set of facts. On one hand, very soon we'll be generating about 13.5 million tons per annum of RDF. If you look at this, where is this waste being generated in this country? Out of the 80 odd million tons or 75 million tons or 70 million tons, depending on which data source you believe, that is being generated today, about 50 million tons of MSW or municipal solid waste is being generated within 200 kilometers of cement plants. So not very far away. So we did a mapping of cement plants. We looked at catchments where solid waste is being generated. About 50 million tons of municipal solid waste is being generated very close to or within 200 kilometers of cement plants. Which means for these cement plants, about 12 million tons of RDF is available potentially today. We don't even have to go to 2025 to 13.5 million. Almost 12 million tons of RDF is potentially available today. This is enough to the point that Pahuja Saab was making, enough to enable a 30% thermal substitution rate. And as he very rightly said, thermal substitution rate is still at 4%. Why the gap? And we'll talk about some of these gaps subsequently, but you can see the scale of both the challenge, but I would also say this is the scale of the opportunity. The gap to potential, why? And very interesting that it's more or less these points that came up during the previous presentation itself. RDF quality and consistency. Unlike coal, waste is not homogeneous. Waste is highly heterogeneous. And therefore, from a quality and consistency standpoint, there is a need for a significant amount of pre-processing. You cannot just, like you mine coal and transport it and burn it, you cannot do the same to waste. It needs a lot of pre-processing. The kiln or the calciner technology, I think there was a mention that was made that some modifications are required to the kiln or calciner in terms of feeding arrangements and in terms of airflow to ensure that combustion is complete and therefore the entire heat value is recovered. If heat value is not recovered, not only is it a problem from an energy loss standpoint, it's also a pollution problem. Cost and willingness to pay, a very, very significant factor. Now, if I take a step back, and forgive me for this comment, Pahuja Saab, today the Indian cement industry sees waste as a revenue line. RDF is a revenue line. It is not a cost line for the cement sector in India. It is one of the most efficient cement sectors anywhere in the world, the Indian cement sector. I mean, the energy efficiency, the cost of conversion, the innovations that have happened in that sector, just amazing. Their own sustainability performance, just amazing. But one of the unintended side effects of that is that they have found efficiency even in the heat value associated with waste, and they see that as a potential source of revenue and not as a cost of energy. And therefore, across the country today, you will find cement kilns either accepting RDF at zero cost or only paying a part of the transport or full of the transport, which basically means, worst case, it is available at the doorstep for no cost to them. So it is a fuel, but it is available at their doorstep at no cost. It's a coal substitute, but unlike coal, which they buy, unlike coal where there are supply issues and substitution issues and import issues and times when cement plants cannot operate because there is coal shortages, the willingness to pay for substitute fuel like RDF, waste-derived RDF, is not the same. And this is one of the barriers to processing, as very rightly said by Pahuja Saab. There is a barrier to pre-processing because in order to take a heterogeneous feedstock such as waste and convert it, it's not that technology does not exist. We'll talk about that in a minute. Technologies exist to take this material and make it suitable at 3,000, 3,500, 4,000, 4,500 kilocalorie per kg of consistent particle size and energy density. It is possible to make RDF of this quality, provided there is willingness to pay. I believe today there is a big question. There are some cement companies who are setting up processing at their end because they are thinking that let's become waste operators. Let's take the waste, let's process the waste, we'll make our own fuel, and then we'll use it as a coal substitute. There are lots of waste managers who have huge amounts of capacity to make RDF and nobody buying it. I happen to be one of them. I believe that this whole ecosystem is stuck. Whether it is the cost issue, whether it is the logistics issue, it's stuck because there's not enough partnership happening. Why should everybody do everything? That is the fundamental issue. If there is capacity available for RDF production, then why should that capacity not be utilized? And if there is a cost associated with processing waste, why should that not be paid for by the consumer of that energy? So these are some of the barriers or gap to potential. I believe carbon markets and the polluter pays principles, those are very, very important factors, policy issues that are enablers for the RDF sector. But I think the biggest enabler would be the cement sector coming and entering into strategic partnerships as a backward integration, as an energy security measure, as a strategic initiative to enhance their own sustainability with waste managers. If waste managers and cement companies come together, I think they will both become more sustainable and both create an ecosystem that is, from an economic standpoint, also more viable. Because the technologies, and each of these technologies, I'll not spend time into that, are currently in play in India at scale. Every single type of these technologies mentioned in this table are being operated in India to make RDF. The question is, if there is no willingness to pay for a particular quality of RDF, then you will do the minimum possible. If there, like it was mentioned, there are 3 grades of RDF as per policy. Actually, even more are possible. You can actually have a basic quality of RDF which has only gone through size-based sorting and some amount of air classification, and you sell it as RDF. That is what is being given to most cement companies free of cost today. Why? Because there's a disposal cost associated with that in a landfill. Land requirement is there to landfill it. for the waste companies, so the waste companies prefer to give it free of cost to the cement companies. Assuming that there was a willingness to pay for higher quality, higher energy density, then a second grade of RDF could be possible, where both in terms of homogenization and in terms of particle size, or the physical properties of the RDF, the quality could have been improved. And then even a third grade, which is much higher quality of fuel, is possible. So technology is no longer the barrier, ladies and gentlemen. This is an example of a MRF that is handling 1,600 tons per day. It's fully automated. There is no human intervention. It is artificial intelligence and machine learning enabled. The more waste it sorts, the better it becomes. And it has a special RDF and an RDF baling line. So technology is no longer the barrier for making high quality RDF today. In fact, Ramky, because it is not able to dispose all the RDF that is generated through this process, which is the MRF process, is investing in significant research, development, and innovation studies in torrefaction. And our idea is, can we move to a future where instead of making RDF using just physical sorting and optical sorting and shredding and sizing, can we go into thermal treatment, and can we go into other forms of processing required to convert the same RDF into green coal?
Mr. Mallick, may I also remind you to come to an end?
Yes, it's just one more slide. So green coal, where much higher energy density, much better in terms of moisture content and low chlorine content, etc., as was being talked about. Again, it's a question of, if a cement company steps up and says, I have a demand for so many 1,000 tons per annum, for us to set up a plant and give them green coal is not a problem. I will not spend much time talking about the benefits of doing that beyond just the cost. Cost is definitely one factor, but the net negative carbon impact of switching away from coal into RDF is so significant. But I must also say there is the competition. This is the competition for cement industries. I am being forced today to set up large waste energy plant. This is our waste energy plant in Delhi. It is India's largest waste energy plant. I set it up because cement companies, would not step up and accept the RDF. So I have to make plants of my own, spending hundreds and hundreds of crores. Here, the cost of energy is so high. It's 25 crores per megawatt compared to solar plants, which is just 5 crores per megawatt. But one is forced to do this because the RDF needs to find a use. And if the cement sector will not use it, eventually other sectors will come up. This is the plant we just commissioned in Hyderabad. So like China, which has 800 waste energy plants, unless the cement sector comes up and other sectors come up, we will be forced to go down this road of having waste to energy and power generation using a very high capex model like this. I hope that will not be the case, because at the end of the day, optimum utilization of RDF in the cement sector is what delivering sustainability and delivering SDGs is all about. Thank you so much for this opportunity.
Thank you very much, Mr. Mallick. And thanks for this really, really interesting presentation, and in parts a very emotional way. I like this very much of presenting this results. The first question is, as always, the money. You talked quite a little bit about the money, and usually for those people who join us and do not know this, usually the budget for pre-processing is the budget between the gate fee that you receive and the price you get from the cement industry. If there is a price, or you have to pay a gate fee by yourself sometimes, it depends on the material. In general, can you say a little bit about this budget? So, because I think this is one of the main hindrances of enlarging the RDF use in the cement industry. Can you say a little bit how common it is for you to receive gate fees for the material that you have?
Yeah, so gate fee in India actually varies dramatically. I have 23 concessions in India. Each concession is unique and different. Different terms, different prices, different standards of performance required under each. One of the challenges in this sector in India is this heterogeneity. Gate fee varies from $5 typically and goes up to $30. That is I'm only talking about processing. So this is the processing fee. Most of India's solid waste spend today is in collection and transport. Most of the ULBs are basically spending almost all of their budget in collecting and transporting waste. And therefore today solid waste management in India is a out of sight and therefore hopefully out of mind kind of a strategy. I will take it somewhere far away and dump it there so that you don't have to worry about it. But then, as we know, cities grow. And today in Bombay, you have Gorai and you have Kanjurmarg and you have Deonar. In Delhi, you have Balaswa and you have Ghazipur and Okhla, these mountains of waste which are within the city today. So I think eventually the country needs to start spending more in terms of processing and disposal. We are happy to say there are many states, every single concession that I operate, we are able to process waste sustainably. We are able to make compost. Sometimes we have to get rid of the compost for free because nobody is willing to buy. Same thing for RDF. And sometimes we are forced to set up our own waste energy plants. Today, I mean, I already have plants operating and I have a large number of plants which are under construction just because I need to process that RDF.
Yes.
Yeah.
For an advice probably for the people posting questions, you should formulate them in a way of a question. We can of course not regard just commands, how you comments, how you think about kind of things. So if you want to post questions, please post them as questions. There is one question: is it possible to make a good RDF without drying Indian municipal solid waste? So can you do that? I have to ask.
We have two partnerships with two Indian cement companies where we are developing customized RDF for them. I believe that if the partnership happens, if cement companies go out, or if waste managers go out to cement companies and they meet and they talk about what do you have, what do you need, I think high quality RDF is not a problem. And it's a question of the environmental cost and the economic cost. Does it make sense to transport medium quality RDF or no? Should we convert it into a torrefied high density green coal and then transport it because the economics become easier? Or the overall carbon footprint associated with transport needs to be kept in mind. So it is a life cycle based decision making and thinking, and it's a question of partnership. I think high quality RDF solutions are available because technology is available, waste is available, and the quality of waste is improving.
Yes, then one question regarding the share of manual work. You showed in your presentation a facility that's 100% automated. In how far in other locations that you use manual sorting still plays a role? And can you say how many, if it's possible, how many people you engage into that?
There is automated processing happening in many locations and some amount of manual sorting happening in almost all locations. But there are only a few fully automated plants where there is no human intervention, very few. I think the future for India also, we are trying out different typologies of MRFs. And I think the future, the ideal MRF for India or material recovery facility for India has some amount of human intervention and human oversight. It is more sustainable that way because we somehow feel that the social value of that job that we create is also to be kept in mind. Not everything should be converted into robotization and artificial intelligence.
Of course. There's one, and that's probably the last question regarding other facilities. So it said, What other sectors than cement plants and waste to energy plants can utilize RDF? I think this question goes towards coal power plants or industrial heating plants. Do you also serve them with RDF in India? Do you have customers there?
Yes. So we are speaking with a very large thermal power giant to explore their thermal substitution requirements. I think just about every industry that is currently using coal will be looking at thermal substitution, and I think wherever there is a thermal substitution requirement, waste, biomass, all of these feedstocks will become viable alternatives for discussion. It is at the early stages today, but I do believe that you will see the first few thermal power plants which are using municipal solid waste come online within the next 18 months.
All right. Thank you very much. Again, we have more questions I can see in the chat window. Again, I ask for, I excuse and apologize that not all of them can be asked in this session. We come to our next presentation, and one question was here the share of manual work in this sorting process, which always has been some share still, even in the highest technology facilities I've ever seen. At the end, there are two guys running around with gloves and picking something out. So we come to this technology, and we just heard that the share of manual work is very small one in the production of RDF. And it's all done by machineries, or mainly done by machineries. And we come to a company that produces such machineries, a company Vecoplan. It's like our company ecoprog. It's based in Germany and is in a fragmented market where we have a lot of suppliers. One of the large companies with a really global presence, I can say, and Mr. Maistry is shows his global presence. He's the area sales manager, being responsible for different countries such as Saudi Arabia, South Africa, South Korea, Australia, and New Zealand, and of course India. He has a degree in mechanical engineering from South Africa and is now based in the United Kingdom. And he's an expert in metal and waste recycling equipment such as shredders, shears, and balers, and has designed and built and commissioned recycling facilities in different parts of the world. Mr. Maistry is not alone here. He's together here with his colleague, Mr. Tim Hammer, the head of sales and alternative fuels. Mr. Hammer will join Mr. Maistry when questions are raised. The presentation is made by Mr. Maistry. Mr. Maistry, thank you very much for being here, and we're looking forward to your presentation. Thank you very much.
Okay. Thanks, Mark. Thank you for the introduction and for the opportunity to present to you today. Special thanks as well to Solid Waste for arranging this. Vecoplan has years an experience in engineering and production of state-of-the-art and high-performance processing plants for the production of alternative fuels from domestic and industrial waste, as well as for handling of material streams for the recycling and waste industry. Next slide, please. I'd just like a few minutes just to give you a brief overview of Vecoplan, if I may. We have over 120 million euros of global sales, 18 active patents, 450 employees worldwide, and with a 20% employee share within the business. Next slide, please. Our head office is based in Germany in a place called Bad Marienburg, which is approximately 1.5 hours from Frankfurt. We do a lot of manufacturing, comes out of this facility in Germany. We also have offices located in the UK, Austria, Spain, 2 in the United States, Poland, and Switzerland. Next slide, please. Our target clientele ranges from the cement industry, recycling companies, RDF producers, and waste management firms, to name a few. As you can see, we also specialize in industries such as data management, sawmills, the timber industry, and the pulp industry as well. Next slide, please. This slide just gives you a brief overview as well of our existing customers. That includes companies such as Geocycle, Veolia, Heidelberg Cement, Cemex, and the Procter & Gamble Group. As we are a global company, we have presence in Europe, Asia, the Americas, and Africa. Listed within this slide are just a few countries where we have an install base, but there are many more that we have throughout the globe. Reducing fuel costs and cutting down on CO2 emissions are the top requirement for the cement industry and its production, therefore resulting in the following materials as alternative fuel sources. So as my previous two speakers has mentioned, MSW, bulky waste, commercial and industrial waste, tire chips as well is quite important, wood waste, textiles, hazardous material, biomass, and other rubber products. So as a company, we can offer products that is necessary for the cement applications. And within the slide and in the next one after this, can be seen a few of our products that's relevant for cement application. We specialize in conveyors, loading stations, storage systems, the screens. This slide that's currently present, if you just go up one, please, Afran. Thank you. Within this slide, as we can see, is some of our existing installations within the cement industry, where we've either installed conveyors, loading for trucks, and various other components. Next slide, please. We do have a vast product portfolio, and this consists of the following technologies that we can offer our clients for a turnkey solution. So we specialize in shredding equipment, conveying equipment, storage equipment, separation technologies, screening, and the dosing systems required for plants and cement industries. Next slide, please. The most common shredder that we supply to the cement industry is our VEZ 2500 or slightly bigger unit known as the VEZ 3200. We can produce material down to 50 millimeters or 30 millimeters as requirements required for the cement industry. It's designed as a can be used as a pre-shredder or single-step shredding. It has a frequency controlled drive, and the intake cross-section, depending on the size of machine, is just less than 2.5 meters by 2.2 meters, or just less than 3.2 meters by 2.2 meters. It's of a single rotor design capable of shredding all types of waste, either loose or in bale format. Next slide, please. Our moving floor bunkers, as can be seen within this slide, has a volume of from 20 to 480 cubic meters. They can be easily disassembled into the individual modules, allowing for easy transportation in a standard ISO container. Just to mention as well that with our moving floor bunker, it's the floor is almost like a step arrangement hydraulically. So what that does is it actually moves the material forward by allowing the floor to move. Our truck unloading stations are of a compact design and able to accommodate different truck types. With regards to the flexibility, we have flexibility on the lengths and widths that we can offer. The discharge ranges from 300 cubic meters per hour for an auger discharge, or 600 cubic meters per hour for a belt discharge. To cover a wide range of material handling requirements, Vecoplan designs and manufactures conveying units to meet a wide range of requirements, such as the type of material and particle size. Our chain conveyors can be fitted to short lines with a steep inclination. Our system is closed, protecting material from the rain and from the wind. They are also made of a heavy duty and robust out of hard oxware plates. Sorry, yeah. One of our signature products within the Vecoplan portfolio is our air-supported Vecobelt, which can be supplied for longer distances up to 500 meters, conveying a capacity of up to 1,200 cubic meters per hour. If we can go to the next slide, please. This illustration gives you an idea of how our Vecobelt works. We have air from blowers feeding the bottom of the conveyor belt along with the other half of the conveyor belt. As you can tell, by air being introduced to the system, this allows the belt to move without the use of any rollers, resulting in low wear and low maintenance costs. So next slide, please. With regards to our Vecobelt, we can offer them in 3 different sizes with a speed of 2.5 meters per second. Smaller size being a belt width of 500 millimeters, and with the larger size being a belt width of 1,000 millimeters. We also manufacture storage systems, which has a capacity of 1,000 cubic meters per box, and is capable of loading and unloading. With our system that we have, it is a possibility to blend materials that may be required for your relative industry. In addition to the other material products that I've mentioned, we can also offer equipment such as drum magnets and disc screens for a removal of extraneous material. I think within the slide, as you can see, we have a drum magnet that will be required for any ferrous separation, and also a disc screen as well, should you require a specific size product to be screened out of your material. In addition to the above mentioned products that I've just discussed, we can also offer the following technologies required for the RDF handling. So we do have a Vecojector for transporting of the fuel. We also provide top loaders and sampling stations and oversized shredders if need be, if the application and the requirement is needed. Next slide, please. Thank you very much for your time, and thank you for your patience. And I'd like to introduce my colleague, Tim Hammer, to the Q&A session, should there be any questions that may have arisen.
Thank you very much. I still have my mic muted. Thank you very much for this presentation. You put back a little bit of the time we've lost. One question regards the specific Indian market. So you are active in different countries such as South Africa, New Zealand, Australia, Korea. Is there something specific about the equipment you need for India? Is it more humid or more, has it a different composition in regards to what you find in other countries? And do you need special technical solutions for that?
I think with regards to our equipment and technologies, is that it's capable for all types of markets. I think as my previous speakers have spoken, if you look at MSW, for example, there's a high organic fraction and moisture content within MSW waste in India. But with our equipment, that's not a problem to handle that sort of material. So we don't have to specifically design or go back to the drawing board and design any equipment capable to use within the Indian market. It is used and installed in a lot of other places and countries where the material is very similar in characteristics, and which works perfectly fine. So we don't need to have any other special application or redesign any of our existing equipment to suit.
What I would like to say to that point is, based on this high moisture content and the organic parts in the Indian municipal solid waste, for sure there's one significant part which is necessary to make a high calorific value fuel. The step of a drying process is one of the major steps which needs to be added. What Ruben said is regarding the mechanical treatment, transport and storage, that's, let's say, stays exactly the same, but the biological drying, that is one key point in the handling of alternative fuels from municipal solid waste. And when I listened to the presentations today and also from the last one from Mr. Mallick, was very interesting to see all the pre-treatment of the waste before it comes to an alternative fuel. Ruben was today focused mainly on the handling side of the alternative fuels inside the cement plant, inside the kiln, and I just wanted to point out that we as Vecoplan have got the whole concepts in the preparation side as well. So really from the raw material up to the high quality alternative fuel. But I think that's another topic which was too big for just 50-minute presentation. So we would really love to present you that one in another webinar in the very near future, and to go to this preparation specifications and possibilities with Vecoplan.
We've one question also regards the cost again. We've heard that there is a certain cost pressure in India, probably larger than in other markets such as Australia, that you also serve here in this unit. How do you respond to that? Is there a higher share of, for instance, local engineering or local content in India than when you install machineries in countries like Korea or Australia? Or is it the case that you have certain products and you serve them no matter to what country?
No, for sure. We are adapting always to the country. So, for example, in a big municipal solid waste treatment plant, for sure there is a quite high amount of steel works, hoppers, sheetings, etc. So there, for sure, this is not something where we are shipping around the world tons of steel. That's something which can be done locally. Vecoplan is capable to provide the engineering for the local manufacturing. And for example, also in India, for sure, there can be also other components integrated from the local market. For example, simple conveyor belts, etc. Okay. So then we focus on the key components to upgrade, let's say, the system and to reach the required process.
Then the last question that has been raised, and also a very specific one. Does Vecoplan makes rotary dryers for municipal waste?
No, we don't manufacture the dryers, but we have got, let's say, some partners for rotary dryers. In general, I can say we don't do the drying part at all, but we have got partners to fill this, let's say, specific gap in the process. Which are experts, and for sure, like the rotary dryer is already very specific. That is always, let's say, based on the available sources of, for example, if you have got some waste heat from your kiln, then a rotary dryer might be an option. Otherwise, there are different other drying technologies available to lower the moisture content below the most probably 20% moisture content. Yes. Which is required.
And I think I stopped the question session here. I think this is the thing that we have to do in the future. Again, this was the first test, and I think, for instance, a very specific issue like drying of municipal solid waste in India could be potential topic of a webinar, because then we really come probably with a more limited audience as well, really to the point where we can discuss very specific individual questions, which is probably not possible today, which I think I did it sometimes already, ask for understanding. We come to the discussion panel with all speakers. I kindly ask you to unmute yourself and to, I see you're all visible. At this time, for the technology, thanks to our colleague Jonas Safe, who is putting on and off everybody and giving the rights. Yes, we've seen really good explanations. We've seen also that some issues and more problematic things have been raised too. I think we saw especially that, yeah, the main thing is it could be more, we could be more compared to other markets, other countries, compared to what the potential is. We could do more in India, we could produce more RDF, we could combust more RDF, dispose it. And I probably want to focus on that. So probably starting with Mr. Pahuja, what do you think has to happen from the side of policy, from the side of waste management in India? What has to happen that it becomes more worthwhile to you to use more RDF in your cement kilns?
Yeah, sure. As I mentioned that in the beginning of my presentation, that Indian cement industry has become the most energy efficient industry in the world as per CSI GNR data. And it is also the lowest carbon footprint company in the world. Not company, the country in the world. The sector itself is the lowest carbon footprint in terms of specific carbon footprint as well as specific energy consumption. Now, there have been very attractive policies with regard to energy efficiency improvement, PAT schemes, etc. And also the energy efficiency pays for itself. As a result of which the industry, otherwise, as he mentioned, that it has been very, very proactive in taking the measures, and it has taken all the state-of-the-art measures. But regarding alternate fuels, since 2001 or 2002, for the last 20 years, industry has been trying hard to increase its alternate fuel utilization, RDF utilization. But unfortunately, the policies have not been that much forthcoming. You see, in countries in European Union or in countries like Norway, etc., where for MSW, the polluter actually pays, even each and every household has to pay. And from that money which municipalities get, they pay the processing fee to the processor, waste processor, and also they make a payment to the transportation, and they also make some tipping fee to the cement plants for making that extra efforts for utilizing it in their plants for creating those extra facilities. So then it becomes a win-win situation for the transporter, for the cement plant, as well as for the waste preprocessor. And this cost is actually borne by the actual polluter, who is the domestic household, mostly, or the industry. So that kind of polluter to pay principle has not yet evolved in the country. That is the reason we are not able to get good quality of pre-processing, as a result of which we are also not able to get good quality of RDF. Cement plants are also, because they don't get adequate tipping fee, they are not able to invest adequate money for creating adequate infrastructure and plant and machinery for proper handling of all these type of RDF in the country. So that I feel this, the main hindrance is that enabling policies are not there for banning the landfilling as well as for polluter to pay principles adequately for creating all this infrastructure for facilitating utilization of RDF.
Mr. Mallick, is it a general question of costs and disposal fees in India? Because if we see it here in Europe, for instance, we have even in waste to energy facilities, they get something between $80 to $150 per ton if they accept waste, just for taking over the waste, the gate fee. And of course, this also has an impact on private markets, more privatized markets, such as the RDF combustion in cement kilns, because the overall price level is just higher. And the competition, I have to say, for the cement industry is higher than in other markets. Would that be a solution to increase gate fees? But wouldn't that mean that the public sector would have massively invest into waste management, and where should come the money from?
Yeah, that's a great question. I think if you were to in any sector which is which needs to take off, which is facing viability gap, if you were to push in a lot of money, it will become viable. But is it truly sustainable? That is really the question. Somebody has to pay, and as my senior speaker prior to me said, the polluter has to pay. The reality of today is that the Indian waste generator has never had to pay a significant amount for its waste generation or its waste footprint. We have only very recently started paying for electricity. We have only very recently started thinking about paying for water. And the fact is that there are socio-political considerations around pushing policy change too fast in order to create the viability for this particular sector. I would think that like in other countries, there has to be a journey where the state supports, not the polluter, but the state supports this transition for a period of 5 years or 10 years. Till the time the overall socioeconomic development happens, and there is a longer term viability, willingness to pay, those aspects become more eligible. And we have seen that in other spaces. There was a time when a big part of the population was not even paying for power. Today it pays for power. Today, a big part of the population does not pay for waste management. In years to come, it will start paying for waste management. Can we wait till then? No. And that is the environmental cost being too high. So the government has to step in. And one of the great enablers for that is carbon. The moment there is a tax on carbon, whether that tax is also extended to landfills, because at the end of the day, it is through these such schemes, market-based instruments, that you can create viability. So taxing carbon, taxing landfills, and enabling government funding for this transition period is the way to sustainability in this space.
Thank you very much. Mr. Hammer, Mr. Maistry, we have received some questions whether urban local bodies or municipalities in India should introduce more pre-treatment plants to produce their waste towards RDF, so it can combust it in cement kilns. From Europe, we know that doing RDF for cement kilns is really an ambitious job. We know that in some parts in Europe, even if they have enough waste, such as Poland or Czech Republic, they import waste for their cement kilns, because the pre-processing plants in these countries currently work not on a level that they achieve to do a quality that is okay for the cement kilns. When urban local bodies would undertake such, let's say, very demanding work, do you have experience with that in India? Do you have local customers who try to manufacture RDF for cement kilns?
So, I mean, as you said, at the end, it's regarding the RDF quality, it always comes down to the point of the gate fee. So, I mean, the private sector, as long as there's no financial target for the private sector, local companies, private companies are not investing in the technology. So The key to success is always, let's say, the governmental support to reach waste treatment targets, to increase the gate fee. And there, Mr. Mallick, I totally agree. If your situation is regarding that point is that the polluter is not paying at all right now. I mean, to cover the full cost from 0 to 100% directly would be a significant change in the system. So I totally agree. There must be some support from the government. Mark, coming back to your point regarding, let's say, starting with, for example, with lower qualities, the good thing is, as long as you are running on a quite low substitution rate in the kiln, even without huge efforts, you could run to a certain percentage RDF with lower qualities in the kiln without having a negative effect or a too big effect on the cement production itself. So this is what we see in different countries. They are starting, for example, with a 5 to 10 ton per hour feeding rate of alternative fuels. For example, in the calciner with a, let's say, low grade alternative fuel, which works for the beginning quite well. So it's let's say already the movement in the right direction to get started with the use of alternative fuel, and then subsequently improve the quality of the RDF and increase the substitution rate in the kiln. So that is what we see in different emerging countries around the world.
Mr. Pahuja, a question I already had in mind. If we talk about the equipment of the cement industry itself, what would your guess how many of the Indian cement plants have installed what we say modern calcinator for the thermal pre-treatment or pre-use of RDF? Is that a common form of equipment in your cement kilns, or are there still many kilns who do not have that?
Oh, I would say nearly 50 to 60% of the kilns have the capabilities to burn these type of alternate fuels, particularly in calciners, because most of the plants are of more recent origin, and that's why the industry is fairly modern, and they have got modern calciners which are capable of handling these alternate fuels. So only with small modifications they are able to handle these small quantities of alternate fuels. But when it comes to increasing the quantity of these type of alternate fuels, when they have to actually feed into the rotary kiln, at that time, most of the plants, they do not have these type of facilities at the moment.
Okay, thank you very much. Mr. Mallick, with regard to time, probably one of our last questions. When you produce RDF, you take different waste streams and let's put it that way, the most valuable parts become the RDF. However, there's a lot of sorting residues, material which cannot be used because Mr. Pahuja would not accept it in his plant. How is the situation there? Is that a problem to dispose in India? Are there high costs putting them on landfills, or are they already thermally treated in more robust facilities such as waste to energy plants, which you also run?
Yeah, so I think out of the 23 locations where I operate in India, 21 of them we are able to either use the RDF ourselves or evacuate it. I increasingly, because our waste quantities are increasing, like I said, we process something like 6-7 million tons a year now, and about the RDF yield from this is about 16% right now. The effective yield after processing, after all the rejects, after everything, so about 16%. So almost 1/5 of the waste that we are processing is converting into RDF. There are a couple of locations where we are storing this RDF because I don't yet have a waste to energy plant. or a cement kiln willing to take it. But we are trying very hard to find, and which is why we sometimes transport this material, give it free of cost. All those other considerations are there, but it's not really scalable. It's not really viable to do this anymore. Places where this is becoming a huge issue, I'm actually setting up waste to energy plants now, which is unfortunate if you ask me, because the infrastructure required to treat and use the heat value is already there in the cement kilns. So it is actually a non-sustainable investment to produce power where actually, you know, there is no power deficit, or other forms of green power are available at a lower cost. But just because I don't want to landfill it, I want to reduce the volume of this waste to just ash, I'm having to set up very high capex waste energy plants. I believe that if there is a concerted effort between the organized players from both sides to come together and find a collaboration space where the requirements of each other can be met, not on a plant-to-plant level, where sometimes the bigger issues are lost, but actually at a strategic level, I believe that this gap can be narrowed.
All right, thank you very much. We have still some questions in regarding what other type of industry can use RDF. Obviously, there's a lot of people here in the meeting who want to offer RDF or pre-waste for it, and whether it's used in the steel industry. Usually not, because they don't they have a higher heat demand as waste can deliver usually. And as we said, for coal power plants and industrial heating plants, you would have to see it's a different issue, because every facility, even every cement facility, has a very individual need for the quality that they recommend and that they demand. And even two cement facilities would not have the same on identical demand, for instance, in regard to calorific value, pollutants or other. Let us close this session with a look into the future. We are in the year 2021. We've talked about the problems, and I think the problems of the RDF sector is you come always to the overall situation in Indian waste management. I think you can discuss a lot of issues and would in the end come to very similar reasons and things to discuss. But if we look into the future, Mr. Pahuja, 4% now, and you mentioned the rates other countries are received. Just a guess, when we look 5 years into the future, what rate would you assume would be will not as possible, but really will be implemented in the Indian cement industry if we are at 4% today?
I think if the policies of the governments continue to be favorable and gradually the things are improving, still I think it may perhaps not increase beyond 8 to 10% on a national basis. Whereas certain progressive individual companies, they can progress. As I mentioned, for Dalmia Cement, we have a target of 35% thermal substitution rate by 2022 end. So in next 3 years, we have a target. And few more companies also are having their targets. And particularly some companies which are multinationals, a part of the multinational consortium, they also have expertise as well as targets, and they are also trying to put up their own pre-processing facilities. But ultimately, it will again depend on the government policies, for which concerted efforts are being made, and through Cement Manufacturer Association, lots of discussions are being held with the concerned ministries. So we believe something positive is going to come up in next 1 or 2 years. And the target for, you see, the cement industry, CSI made a target that by 2030, nearly 30% of the thermal substitution rate should be coming from the waste alternate fuels. So if the policies are really enabling, I think that should really be happening.
So the next time
wastes are available. There is no dearth of waste.
So the next time we discuss this issue, we have to invite somebody from the government. We probably will do that. Mr. Mallick, what do you expect? 5 years time, what is your guess? How much RDF will the cement industry use in percentage of their energy input?
Yeah, so I really can't predict for the cement sector per se. I will say this. We as a company have taken a decision that if in the form of fluff, which is the form in which RDF is currently being sent to cement kilns, if that is not the appropriate form of RDF for cement, we will move into pellets, we'll move into briquetting, we'll move into other higher density forms of RDF, which are suitable for other sectors. So I believe that offtake of RDF conceptually will be order of magnitude times more, because I'm seeing that within the last 18 months, 2 years, how much change has happened. Whether it is to WTE, whether it is to other consumers, or whether it is to cement, that remains to be seen. But I believe that we will see many times more consumption of RDF and diversion away from landfilling in the coming 2, 3, 4, 5 years than we have seen in the past. Whether that happens through the traditional fluff to cement model, or pellets and briquettes to other industries, or even fluff form for waste to energy, captive waste to energy, that remains to be seen.
All right. And last question to Mr. Hamer. In how far, what we heard today, you're like I myself, you are located in Germany. Do you think that India, with this development, will play a much bigger role in your activities in the next 5 years?
Yeah, absolutely. So together with Ruben, I mean, our focus will be, or one of our focuses will be on the Indian market. And I can ensure that in the increasing of the total substitution rate in the cement plant, Vecoplan will not be the limiting factor. So, so we will be ready.
I'm sure about that. Yeah.
we will be ready to develop individual concepts on the local requirements. Absolutely, that's our engineering team is ready, and Ruben will be in India frequently to discuss opportunities and projects. With parts of this audience and with further people which are interested in the use of alternative fuel. So we can share also some knowledge which we gained here in Europe for the Indian market.
Yes, I close the session now. I thank you all very much. I hope that all the people in this webinar could